Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessments, and in today's course we are going to cover risk and risk assessment. How do we undertake that? And we'll look at the methods involved within this. So the key reference for us is chapter 18 from our textbook, which we are referring Therivel and Woods. So today's coverage would include, we'll look at the definitions and concepts, what are the various definitions involved about risk, and all the terminologies within that. And then we'll look at what are the risk assessments and what's the management framework. Further, we'll look into the methods involved with prediction and evaluation, what approach do we adopt in that, and we'll look at the mitigation aspect, and then we'll also look into quantitative risk assessment, QRA, and environmental and social impact assessment. What's the relationship and how do we deal with that? So accordingly, the learning outcomes, expected learning outcomes, is that you should be able to define and explain the involved key concepts in this particular domain, and then you should be able to review the framework involved in the process. Further, you should be able to identify methods and approaches involved in prediction and evaluation, and then identify the various mitigation approach which would be taken in this, and then also discuss the quantitative research assessment and the environmental and social impact assessment within this domain. So when we look at it, we see that risk is more an idea or a concept. What is risk? So it involves a lot of judgment that is perceived, like we feel the risk, rather than what really happens. So it's more of a risk which is perceived by the individual than the fact what really takes place on ground. So you might be afraid, you might be thinking about what might happen if you go somewhere, and then the actual fact is whether that accident would happen or not happen. So that is what we call risk. And when a risk is realized, then definitely the impact occurs, which is in most cases, if we see the risk is a negative terminology and it relates with negative impact. So risk has negative connotation. And risk is also aligned with uncertainty and probability, because things may not happen. So risk, if you look at the term, risk means exposure to the possibility of economic or financial loss or gains. So it can be any kind of risk, and then the physical damage or injury or delay, whatever might happen because of the consequences of that particular event taking place. So looking at the involved definitions and concept here, so risk is an outcome of hazard. If hazard happens, hazard or hazardous events, so what is the result of that is the risk. So hazard is the inherent property of an object. So a certain object can be hazardous. So it's the property of the object to create damage to humans or the environment. So if those things happen, then the resultant is the outcome which happens is the risk. And these objects can be inherently dangerous, and exposure to them can cause injury, health problems, or loss of environmental quality. So these hazards can cause harm in one or two ways. So if we see what the damage can happen, so the damage can be long-term exposure at the low level. So you're exposed to something for a long term and the level of exposure is very low. And the other can be, you can be exposed in a very short term, maybe few seconds or hour, but the exposure can be of very high level. So you see these two ways it can cause you harm. And then the hazards that cause harm over a period of time through long-term exposure typically include, the examples include like the toxic chemicals, pesticides, radioactive material, all these X-rays and things like that. Isotopes which are used in the X-rays. So long-term exposure to all those, so that can cause, and then you and all these things are said to be chronic hazard. So the chronic hazard is the exposure caused to humans by extended exposure, but of the relatively low levels. And then you also have natural hazards. So like example is fertilizers cause ecological damage. And then you also see fertilizers that end up in wetlands and cause algal blooms. They can be slow or can be rapid with accidents. So these natural hazards can also be slow or they can be rapid as well. Then you also have hazardous events where humans or other species are exposed to the hazard at a levels, and then it causes damage, harm to human or the environment in a very quick manner. So that's the hazardous event. And in all these cases, the hazard results in an accident where very high level of toxic chemicals or radiations are produced. So for example, you can see we have already seen this case before, example case of Bhopal gas tragedy, where we had seen 1984 leak of methyl isocyanate gas at the Union Carbide pesticide plant. So this is extreme example of such an accident. So there have been other examples also. To 2010 explosion of Deepwater Horizon oil platform in Gulf of Mexico. So that resulted in over 1,000 kilometers of coast being affected directly by the mixture of oil and chemical dispersant. You can see that as well. So seeing risk, what's risk is equal to likelihood that harm to a human or the environment will occur as a result of exposure to the hazard. So there is a probability case and there is a hazard. So what kind of damage will happen if based on the likelihood and the hazard, so if the human beings are exposed to that hazard. So you'll see that risk is seen as a combination of these two factors. So you'll see likelihood, which is frequency, and hazard, which is the consequences if the interaction happens. So frequency for chronic hazard is about the length of time, or how much you are exposed to the hazardous chemicals, or the number of times that exposure occurs. So and you'll see as the length of time increases or the number of exposure increases, the risk also increases more to cause the damage. And you also find acute hazard, which is like frequency is more generally about how many times a certain type of accident occurs or how often things go wrong. So the consequence, the result and the risk refers to how serious is the harm and the risk here. So risk is, if you'll see in a very simple term, is frequency conceptually multiplied by consequences. So you will also see that these risks can be of individual concerns or societal concerns. So individual concerns relate to how individuals perceive risk from a particular hazard. So how it affects them directly, how it affects things they personally value. So that's individual concerns, and these concerns can be quantified also. And then there are certain societal concerns, and then there are broader concepts which relate to hazard that impact these society in larger compared to individual. And mostly our focus is on the societal concerns compared to the individual concerns. So now understanding risk assessment. So what do we mean when we say risk assessment? So it is the process of estimating. You are going to calculate the level of risk that a hazard has, which poses on the that calculation is called risk assessment. So the broader risk management strategy would involve that you're going to estimate the likelihood of an adverse outcome. So that you would, based on this, you're going to develop the broader risk management strategy. You're going to estimate the likelihood of the adverse outcome, and you would also, within this, you will also provide useful data on which all the authorities, the involved authorities which operates or make the decisions, are going to try to reduce the risk. So now you see that these assessments are done in the quantitative format as well as qualitative format. So looking at the quantitative risk assessment, QRA, so here you try to quantify the risk, and the process involves evaluating and assigning a number value to the risk. So you give a number to it, and also includes the practice of probabilistic safety assessment and probabilistic risk analysis as also PRA. So here, looking at the QRA process, you see the how do you identify the QRA scenario. You look at the frequency of assessment and what are the different outcomes. So here you can you have this guideline, quantitative risk assessment QRA guideline, very detailed guideline which is there. So I have given you the link also to that. So it looks at what kind of how do you do the frequency assessment. So you undertake part counts, or you also draw event tree analysis, or you also have physical effects modeling or vulnerability analysis. Based on that, you look at the risk analysis, where the output can be in form of a contour. You can draw risk analysis contour, and then all format of IRPA, PLL, FN curves. So all these are the ways how you represent, depict the risk. And then risk evaluation shows the sensitivity analysis, and then you can also link to the cost benefit analysis. So some of the examples here are semi-probabilistic presentation of QRA results. So you can see here asset risk matrix, so likely, unlikely, very unlikely, extremely remote. So you have like how moderate, serious, severe, major, extreme is there. So you're drawing the matrix. You're also looking at the probability of it happening, and then what happens with if it happens in a moderate or in extreme cases, so what kind of things will happen. So semi-probabilistic presentation of QRA, you can see here environmental risk matrix, reputation risk matrix, or these matrix have been given. So what will happen to the property, what will happen to the environment, and what will happen to the reputation if these kind of things happen. Then you can also see these modeling output here, how they are looking at how it is showing you the scenario from which the red one is the highest risk which will happen to the outer, how it's along the space, how it is going to happen. So you can see these modeling output here. Then there's also a framework for tolerability of risk. So you see this framework here, which is like how do you really make, because it's involved, it's very perceptual, and it involves a lot of judgment as well, and there are standards and guidelines for the acceptable level. So here you see there are certain if you look at this inverted triangle, you see that the topmost is the unacceptable region. Risk cannot be justified except in extraordinary circumstances, so that is unacceptable region. Then you have this between the unacceptable region and broadly acceptable region, you have ALARP region. Risk is taken only if a benefit is required. So this region, ALARP region, you see the tolerable only if the risk reduction is impracticable or if its cost is grossly disproportionate to the improvement gained. So if it is very, very expensive, then you might have that in the buffer case, and if whatever mitigation you're taking, it's tolerable if the cost of reduction would exceed the improvement. So you see that how these decisions are made. So a common form of presenting risk tolerability criteria for societal risk is in FN diagram. So in that also you saw that we show it in FN curves. So where two criteria lines are divide the space into three regions. So where you have like intolerable, where it is broadly acceptable, and where it requires further assessment and risk reduction as far is reasonably practicable. So here you can see FN curves. Here you can see all the areas. So these line example of FN curve. Here these curves you can see. So above the red zone you see it's intolerable. Within a red and blue zone you see further assessment and risk reduction required, and then the below blue line you can see broadly acceptable things. So the FN criterias are really used, and then if you look at the benefits and limitations of FN criteria is like it shows the relationship between frequency and size of accidents, and then you also it allows the judgment on relative importance of different size of accidents, and then you look at the steep slope, which helps you to make further decision on like how you can manipulate information, and it also allows company to manage overall risk. So this has certain advantages, but the limitation include cumulative expression makes it difficult to interpret. Certain time interpretation is difficult, and it can be difficult to derive and maybe difficult to use the criteria if we are using it in one area or more than one area. And this is also debatable about the location of lines. So that way there are benefits as well as limitation. So now moving on, looking at the risk assessment and a broader risk management framework. So here you see four broad steps, as you can see in this stage here. So in this risk assessments, we do first is that you identify the hazards. What are the hazards? What things can go wrong, and then if they go wrong, what consequences will happen, and then what are the likelihood that the things will go wrong, and then you find out what nature would be, to what extent it would happen, what kind of impact would happen, and how many people, how much area would be affected, and then establish acceptability of the risk level. So if what kind of risk we can accept, and which risks we won't be able to accept, and that you have already seen. And then after this, you have a post assessment where you do you see the last step in the risk assessment. So if the risk level is found to be acceptable, then no further action may be required if it is in the acceptable range. And then the proposal can proceed, especially if the risk is negligible. So looking at this post assessment, here you make the decision. So you look at the proposal may be required to reduce risk further if risk is unacceptable or is refused, or you can go ongoing control is there, and then you can continue monitoring and controlling of the risk. So this is post assessment. So that was about risk assessments and the broader risk management framework, which is usually followed in a very simple manner. Now looking at prediction and evaluation. So you have seen quantitative risk assessments. So if you look at quantitative risk assessment, what's the outcome of quantitative risk assessment? So the key outcome of quantitative risk assessments are the risk contour lines around the hazardous facility. So you saw a range of outcomes of when you do this assessment. So one is the risk contour lines. So each contour lines represent a line of equal risk of any individual standing on that line. So these contours are generated from all the sophisticated models which are used, and they will include, they would show you the data They will tell you about the nature of chemical hazard and the levels of what kind of impact would happen, quantity of chemicals on site, nature of technology used, and known what will what accidents, leaks, and exposure would happen. So it would show that, and it would also depend on the local meteorological conditions, local site characteristic, and nature of emergency response proposed. So not just on the insight information, but also based on the external factors also. So these contour lines would, the QRA would show you all these aspects, and contour lines, risk contour lines would also show you. So here you can see the example of risk contour for multi-facility site. So you can see all the inner polygon, then you see the yellow, and then you can see the range of colors which you can see here. So how the risk is going on reducing, at the risk is higher at the center, and now it's going on reducing. So for undertaking all these, you need certain data source, and mostly there are a lot of agencies which maintain accident and frequency of accident data. For example, you have oil and gas producers data, which you can see here. I have given you the link. So these kind of agencies maintain data of accidents and possibility of accidents. And the QRA has been criticized also for being very narrow. It gives very stimulated modeling results. So there are limitations to it. And then there are also criticism about its being focused on the equipment failure, but then there can be chances of human errors also, like there are a discussion on Bhopal gas tragedy, which was combination of human and equipment failure. So now looking at how do we determine the acceptable risk, So in QRA, we see that what level of risk is acceptable, what is tolerable and acceptable. So when we say tolerable, we mean willingness by a society as a whole to live with the risk, so as to, like, there are certain benefits you get from whatever activity you are doing, so you are willing to undertake that risk in order to gain that benefit. So that's the tolerable level, what you mean here. And it is also guided by the political processes, and then there's also like what kind of exchange is happening between the benefits and the risk which is involved here. So when you say acceptable, it means risk levels lower than the tolerable level and can be considered acceptable. And this does not mean that once the level tolerable risk has been established, every individual will accept it. So it might also vary from context to context, from individual to individual as well. So you also see there's a difference between, we had seen the diagram, between what is acceptable and what is not acceptable. So we had seen the diagram ALARP. So as low as reasonably practical. This is what philosophy we follow. So risk in between the two values is often called as ALARP region, as low as reasonably practical. And while it is preferred that the risk levels are reduced to minimum, what minimization which you can do, the risk within this range can be acceptable if reducing the risk level further is either like it is not cost effective, or it's not practically possible to attain it, or it loses the trade-off which we are making, it no more is beneficial for us. So you can see the diagram here of ALARP, as low as reasonably practicable. So here you see increasing risk reduction regardless of the cost, that is intolerable. Then you have tolerable if it is low as practically possible. So that's the ALARP range you are seeing. And then relevant good practice, because of good practice and standards and maintenance which you follow, broadly acceptable level. So you see that nations have adopted criteria for tolerable and acceptable risk levels. So you have various, like all these range of countries which have adopted criteria for tolerable and unacceptable risks. So they have these. And then you have seen quantitative risk assessment, you also have qualitative risk assessment. So here you don't number, but you provide description for the information. So that allows for comparison of options. So that include the views of the experts, and sometimes even the views of the stakeholders, experiences of the stakeholders, and then it allows you to make the assessment based on the what kind of descriptions and descriptive information you have. So in this also the same general approach adopts the risk equals to frequency into consequences, but in this case you don't come with a number, but you come up with a description. So you can also have risk matrix, which is used here, so which tells you the two-dimensional aspect of it, as you can see here in this matrix. So you can see it is describing, it's not giving a number. So likelihood of adverse outcome, what's the consequence level, minor, moderate, major, extreme, and what are the chances of its happening, remote, unlikely, possible, likely, given the cases or experts' opinion or stakeholders' experiences. So there are a lot of methods which are available for risk analysis. So you can see risk analysis which have like Delphi technique, you can have SWOT analysis, SWIFT analysis, and then you can also see ICOR, improvement, challenges, opportunities, and risk analysis, bow tie analysis, decision tree analysis, risk probability and impact assessments, and probability and consequences metrics. So all of these are available for undertaking qualitative risk analysis methods. So we'll not get into the details of all these Delphi techniques and SWOT analysis, but for our understanding, these techniques are used. So now looking into the mitigation aspect. So once you do the assessment, risk assessment, especially when you undertake QRA, quantitative risk assessment, or qualitative risk assessment, the purpose is to inform the decision makers of both policymakers and the people who are going to be affected. So you inform them. The purpose is to inform. So and then your mitigation can be in form of land use planning decisions, where to locate what kind of things, and also what kind of standards you're going to follow as per the acceptability of the risk to human health and safety. So what you try to do is you have certain mitigation hierarchies. So first you try to reduce. If the risk is too high, then proposal will be required to be modified to reduce the risk to the acceptable level. And if that cannot be done, then you need to avoid. If the risk is too high, then an alternative locations can be considered for the industry, or no sensitive land use could be permitted within the tolerable unacceptable risk contour. So if any sensitive land use is there, you have to avoid it. So you follow these mitigation hierarchy. Now looking at quantitative risk assessment and environmental social impact assessment. So you are dealing with quantitative risk assessment and EIA. There's a link between that. So you see that both QRA and EIA are about, like, you are looking at the impact of new any kind of proposals which is coming up. And you look, but what you do in QRA focuses on human health and the safety aspect of the proposal. So when you're looking at the risk, we are looking at the human health and safety aspect of the proposal, while when we are looking at EIA, we look at the broad range of environmental impact. So if you want to understand the difference between the two, when we do the risk assessment and when we do the environmental impact assessment, so then we are looking at the impact on the environment, and here we are looking at the impact on the human beings. So QRA can be seen as a tool which allows, which is within the EIA process, and though it has a similar theory, but it's looking, the focuses are different. In QRA, you're looking at human beings, and EIA, you're looking at human as well as the environment altogether. So there are certain quantitative risk assessment report. I have given you the link here. You can see here how they are analyzing what kind of incident would happen, no release, tanker explosion or release will happen, then what kind of scenario will happen. So these kind of flow charts for consequences are built. So these are some of the technique tools which I use to analyze. Then you can also see here from this example fatal radiation exposure level, how they are creating for different scenarios with radiation level, and then fatality. If it happens, then what would be the percentage of damage which will happen. So you can see here, this is event tree for continuous release. So here I want to show here is the event tree. So how you analyze what kind of event from if any accident happens, then what will happen here. And then you can also see here from their report. This report I have taken from Vari Specialty Chemicals. This is from Bombay, Nasik Mumbai Highway. It is the example is from Bombay. So here you can see how they have done modeling, stimulated the scenario and see so like pool fire results, if the fire occurs, how it will happen. And then there's another example which you can see, Vapi production industry, so how they are taking risk assessment and disaster management plans. So I've given you all these case studies which you can see. You can see the quantitative risk assessment, the methodology, what they have followed here, and then how they have addressed the ALAP principle, and then what kind of hazardous chemicals which are there, then all the modeling map and risk contour. So here you can see the example of risk contour again. So how they have drawn the risk contour. So what kind of exposure will happen at the blue line, green line, red line. And different scenarios you can see. Likewise, they have done the like how the toxic effect would be for different chemicals, and then they have also created scenarios for that. Then also you can see the again for different nitric acid, what scenario they have created, and then the contours they have created. You can see the cloud footprint, and then how they are showing the maximum concentration here. Then you can see pool fire scenario, fireball scenario, so different scenarios they have built here. So I will not get into the details of it, but just to understand that what all are the ways they depict and how the information is communicated. So that is what all we have in this particular session. So summarizing, we looked into the definitions and concepts, then we looked into risk assessment and broader risk management framework. Then we looked into how we really predict and evaluate. We looked at certain few limited examples, and then what approach we take for mitigations, what are the mitigation hierarchy, and then we tried to differentiate between quantitative risk assessment and environmental impact assessment. So that was all for today. These were our key references for this particular session. These are the suggested watch and read. And winding up, I extend my thanks to you. Please feel free to ask questions. Let us know about any concerns you have. Do share your opinions, experiences, and suggestions. Looking forward to interacting and co-learning with you while exploring EIA. Thank you.